Welcome to this video lesson which covers the full solution to the practice questions from the basic vector lessons in the vector series. In the first question, we are told that we have a plane that's steering northeast at a speed of 200 kilometers per hour. We have a wind speed of 50 kilometers per hour coming from 30 degrees north of west, and we want to determine the velocity of the plane relative to the ground. First, let's draw all the information that we have. We know that the plane is steering northeast at 200 kilometers per hour. So actually my coordinate system first is going to be east and north as positive. So we're going to have north here. We're going to have east here. And this one is going to be in this direction. Its magnitude is going to be 200. This is the speed of the plane, and we know the angle is 45 degrees because it's exactly northeast, so that angle is half of 90 degrees. Let's draw the wind speed. So the wind we're going to have, I'm going to draw the whole coordinate system for this one. We're going to have north, east, west, and south. We know that the velocity is west 30 degrees north. So first we go west in this direction, turn 30 degrees towards the north, and that's the direction at which it's coming from. So it will actually be pointing in this direction. It's going to have a magnitude of 50, and this angle over here needs to be 30 degrees as well. And the reason for this is because we got two lines crossing, and using X pattern, if this angle is 30 degrees, this angle is also 30 degrees. Now, the velocity of the plane relative to ground can be calculated by adding the two vectors here. So the plane velocity plus the velocity of the wind. And the plane velocity is going to have its x and y component. Let's do those. So the x component of the plane is going to be in the east direction. That's positive because that's same as our coordinate system here. And this side is adjacent to the angle, so it's going to have a magnitude of 200 cosine of 45. So I'll write that here, 200 cosine 45. And for our y component, it also goes in the same direction as our positive coordinate system. So, and since this is opposite to our angle, this is going to be 200 sine 45 degrees. So this will be 200 sine 45 degrees. For our wind, it's also going to have an x and y component. For the x component, it's going in the positive x direction, or in the east direction, and this side is adjacent to the angle, so it's going to be 50 times cosine of 30 degrees. So that's 50 cosine of 30. And for the y component, it's going opposite to our coordinate systems, because our coordinate system is pointing north, this is pointing south, so this is going to be negative. And since it is opposite to our angle, it's 50 sine of 30, so that's 50 sine 30 degrees. And when we add these, we have to add the x components together, so that's 200 cos 45 degrees plus 50 cosine 30 degrees, and the y components, that's 200 sine 45 minus 50 sine 30 degrees. And we will end up getting an x component of 184.72, and the number continues. I will use approximate here, and 116.42 for our y component. Now we have the x and y component of our ground velocity. We do want to express it in terms of its magnitude and angle compared to either east or north or west or south. So I'll do that part here. We know that its east component is 184, so that's going in this direction, so approximately 185 actually, and its north component is approximately 116, and the resultant velocity is going to initiate from here and terminate here, and that's the ground velocity. So the magnitude of that velocity is going to equal to the root of, it's the approximation again, 185 squared plus 116 squared, and I'm using the exact values on my calculator, not just the estimated ones, to get a ground speed of 218 kilometers per hour. Now that I have the magnitude, I also want to find the angle here. The angle, I'm going to use tan of theta is equal to the opposite. Opposite to the angle is 116, and the adjacent to the angle is 185. And theta will equal to, or is approximately equal to the tan inverse of that, which is equal to 32.2 degrees in 3 significant figures. To write my final answer, velocity of the plane relative to the ground has a magnitude of approximately 218 kilometers per hour, and its direction, it goes in the east direction and then turns at an angle of 32.2 degrees towards the north direction. And that is my final answer to this question. Okay, in this question we got a pilot who wishes to fly an airplane south 30 degrees west of the present position. If the average airspeed is 500 kilometers per hour and the wind is coming from north 70 degrees west at 60 kilometers per hour, determine A, the direction that the pilot should steer, and B, plane's ground speed. This question has a lot of information, so we kind of have to break it down. Let's actually draw it out. The pilot wishes to fly an airplane in the direction south 30 degrees west of the present position. So if the position is here, then this is the initial position, let's say position 1, and the pilot wants to go south 30 degrees towards west. So that will be in this direction. We don't know the magnitude of this, and we know the wind is coming from north 70 degrees west. So I'm going to draw that here. North 70 degrees west. So the wind is coming from this direction, so it must be going here. So using opposite angles, this is, if this is 70, this is also 70 degrees. And this is going to be south and west. And so that's the wind direction. And we know that this is going to be 60 kilometers per hour. And we know that the average airspeed is 500 here. So that's the magnitude of the velocity of the plane. This one over here is the magnitude of the velocity of the wind. And we know that this one over here is the direction of the ground speed, or that's which way the plane actually wants to go. So I am going to label this one as VG. And we know that VG is the addition of the two vectors, VP and V wind. So V wind is going to be going in this direction. So that's VW. And therefore, VP has to be going in this direction. Now, putting everything together, actually, I'm going to label this as VP. And putting everything together, the plane is going in this, the plane vector is here. We add VW to it, and we get VG from that. Let's put all the information that we have in this question. So we know that for the wind, this angle over here is 70 degrees. And we know that the magnitude of the wind is 60. So that's the magnitude of this side over here. VP, we know its magnitude is 500. So we can write that in, 500. We don't know the magnitude of VG, and we don't know any other information actually. There are two different ways of solving for this question. One is to break them down into their components, and we will, once we do that, we will say that VG is equal to VP plus V wind, and from there we'll have two equations and two unknowns. One of them will give us the angle that we need to find the direction here, and one will give us the ground speed, so we can solve everything in there. But what we're going to do, we're going to use a different method for this, because it's important to know that questions can often be done using different strategies. Here we have this side, we have the magnitude of this side, and we have this angle over here, we have this angle over here, and we can use this set of information to find this angle over here. Let's see how. I'm going to draw a horizontal line here. This angle is going to be 90. And if this angle is 90, that means this angle is 30, this is 90. They add up to 120. This is a triangle, and therefore this angle will be 180 minus 20, and it ends up being 60 degrees. Now, we can do the exact same thing for this one. We know that we'll just draw a horizontal line, and this angle is 70. This angle over here is 90 because this is a vertical line, this is a horizontal line. So 70 plus 90 here will give me 160, and this is going to be 180 minus the 90 minus the 70, and if we do that we will get, actually I'll write it out, 180 minus 90 minus 70 gives us 20 degrees. To find the angle right in between here, we know that this angle is 60, this angle here is 20, and all of these angles here add up to 180 degrees because we have a straight line. So the orange angle is going to be 180 minus 60 degrees minus 20 degrees. And that's going to give us an angle of 100 degrees. Now I have this angle and I have this side. I have this side and I can find this angle. And once I find this angle, I can use that set of information, add it to the 30, and that would be the angle for which the pilot has to actually steer. So that will give me enough information for that. So to find this angle over here, theta, I'm going to use the sine rule. and the sine rule says that sine of theta over my side 60, the opposite side, is going to equal to the sine of 100 divided by its opposite side's length, which is 500. I'm going to rearrange sine theta is equal to 60 times sine of 100 degrees divided by 500, and I will get sine of theta is approximately equal to 0.118, and therefore theta, taking the inverse sine, will be approximately 6.79 degrees. And I will keep the exact value and use it for my other questions. Now, to answer part A of the question then, it's asking at what angle or what direction should the pilot be steering? Well, we have this angle, which is 30, and we're going to add that theta angle to it here. That's 6.79, and that's going to be in the direction south towards the direction west. So we can do this and say the direction needs to be in the direction south, and then 30 degrees plus 6.79 degrees towards the west direction. Adding everything up, we will get south 36.79, and in three significant figures, that would be 8 degrees towards west. For the second part of the question, we're asked to figure out the plane's ground speed. So speed doesn't have a direction. We just want to see what the magnitude here is. And we have enough information now. We have this side, and we have all the angles as well. So we can use either cosine rule or the sine rule to do this. In either case, we do need to find this angle over here. We know that this angle plus this angle plus this angle will equal to 180 degrees. So to find the purple angle, we have to do 180 minus 100 minus that angle there, which is 6.79 degrees approximately. And that's going to equal to, and this is approximation again, 73.2131. I'll write that out here, that's 73.2 degrees. And once I have that for part B, I'm going to let's use the sine rule again. It's a little bit less messy than the cosine rule. And we know that magnitude of VG divided by sine of 73.213 is going to equal to, let's use this side and this angle. So that's going to be magnitude of VP, which is 500, divided by sine of 100 degrees. So again, we use magnitude of this divided by the sine of this opposite angle, and that's equal to the magnitude of this divided by the sine of its opposite angle here. If we rearrange this, we get that the magnitude of VG is equal to 500 times the sine of 73.213 divided by sine of 100, and that gives us approximately, and this is also approximately, 486 kilometers per hour in three significant figures. I hope that this video was helpful in giving you some practice to basic questions involving average velocity in the vector unit. Thank you for watching.